this down. There we go. Find two ratios that are equivalent. You guys ought to do that. A fancy one, right? Multiply the top and bottom by 2 over 2, 3 over 3, 7,000 over 7,000. It doesn't make a difference. And you can get a lot of possible different answers here. You guys know how to expand and reduce fractions, right? Yeah, that's what I'm hoping. All right? So, problem of the day, we're not going to do ink and math. All right? Learn to solve proportions. So, this is, as Taylor said, kind of pretty much the butterfly method. The cross multiplication is really what I need you to know. Butterfly method, cross multiplication are the same thing, okay? Because otherwise you're going to be using that, and in high school you're going to be lost. All right? Cross products is what they're going to call it, okay? So pretty much what it says is, if you multiply across and down, you get the same. They are equal proportions. If they are not equal, well, then the fractions are not equal, okay? So as we go on, we're trying to see if they're equal or not. So you can always use cross products, and you can get 60, and you can get 60. That is a way to check it, or your other option, because I always want you to have a secondary way to do something. You can get common denominators, but my suggestion to make it as easy as possible for you, reduce it down to the simplest form. 2 over 2, that's 2/5. That's 2/5. 3 over 3, that's 2/5. If you get them both to the simplest form and they are the same, then you can know as well. So you can do the cross products, which is a very good and fine way. If the numbers match, they're equal. Or you can reduce down to the simplest form, and if they're both the same fraction, they are equal. So notice with proportions, there is an equal sign between them. That is important. All right? And 5/3 was converting, right?
It was.
Yeah.
Mm-hmm.
Okay. So on we move. Now here's where you're going to be using this stuff at. All right? So a mixture of fuel for a certain small engine should be 4 parts gasoline to 1 part oil. So when you set this up, 4 parts gas to 1 part oil. Okay? Make sure you label things. Okay? Make sure you label things. When you make a chainsaw, when you have many of your weed eaters, a lot of these things are there. All right? What's on there that's so important? Because I'm like this close to taking it away for the rest of the day.
I thought I did something like this on 5/3
5/3 was due today, so we did that Wednesday.
I thought I did this right.
You did it already? Okay, all right. 5/4 was out there. You may have looked at it, so you may have kind of but it's been out there. So if you combine 5 quarts of oil with 15 quarts of gasoline, so with that fraction, if I'm combining these parts daily, what goes on top of the fraction? What goes on bottom?
15 over 5.
15 over 5. All right, Lucas, did she do it right? Did she put gas on top and oil on bottom?
Yeah.
Yes, she did. So we have gas parts to gas parts, oil parts to oil parts. Good job comparing. So now what do we do, crew, to compare them? You can cross multiply. So 1 times 15 is 15. 5 times 4 is 20, and no, they are not equal. All right? So they are not equal. Very good, very good. So setting them up is probably the hardest part. If you label things, you won't have a problem. With these, they're pretty simple. You can probably already see counter. Is this one equal or not?
Yes.
He says yes. All right? You can always go down and have 20 and 20. Yes, they're equal. I like divide by 2. Divide by 2, you get 1/2. All right, divide by 2 over 2, or 5 over 5, you get 1/2. Both ways will always work. It's whichever you prefer, okay? Okay. So, a mixture, Christine. of a certain brand of tea should be 3 parts tea to 1 part sugar. So what do you want to make the fraction look like?
3/1.
Okay, 3 tea to 1 sugar. And I really advise doing this. Now, what if I told Christine I want to do 1 sugar over 3 tea? Did what she do it wrong? Is what she did wrong? No, not at all. Is what I did wrong? No. But are our fractions on the other side going to look different too? Yeah. So when we read this next part, Michaela, if you combine 4 tablespoons of sugar with 12 tablespoons of tea, so what does that fraction look like compared to this? What goes on top, what goes on bottom?
Four goes on bottom and 12 goes on top.
4 goes on bottom and 12 goes on top. Trenton, how did she do?
Good.
Good. Because 12 tablespoons is tea. Oh, tea was on top, right? 4 sugar. Sugar was on bottom. She did great. Well done, Michaela. All right. So what about this bottom one, Tori? What's this bottom equation going to look like?
12 at the bottom and 4 at the top.
All right, Gavin. Why did she put 12 at the bottom and 4 at the top over or down here on the bottom section?
T is on the bottom, 3 is T, and then 12 is up.
All right. Tea is on the bottom. Sugar's on the top. So sugar on top and top. Tea on bottom and bottom. Tea on top and top. Sugar on bottom and bottom. So I really like the way Christine did it. There was nothing wrong with what she did. But are both of these essentially the same thing? You have the same proportions. You have sugar to tea, sugar to tea, tea to sugar, tea to sugar. As long as you stay consistent, you're fine. All right? That's what I wanted to put out there. So if you're comparing and you're looking and Crew and Tori get together and Tori's got this and Crew's got this, they both did it right. Right? All right. So, and Jake, you probably saw that there was a lot of overlap between them. When we do this, we get 12. When we do this, we get 12. Many of you are already saying, yes, they're equal. All right, good job there. All right, now online, you got the next one. Bruce and Daniel, going to you. Carson will get you on the next one with Connor. The ratio of boys to girls in a soccer league is 5 to 4. Now, from reading on this, Bruce, the boys to girls. So which number represents boys and which number represents girls? You may still be on mute, Bruce. Okay, look at the order they listed them in. Boys to girls. 5 to 4. All right, Christine, help him out.
So 5 is the boys and 4 is girls. They always list like the one is first, the one.
On top. Order is important, right? All right, so Daniel, when I come to you, if there are 52 boys in the leagues, how many girls are there in the league? So Daniel, when we're setting up this equation, where do these 52 boys, do they go on top of the fraction or below the fraction?
On top.
All right, because boys need to be across from boys, right? All right.
Yeah.
But what goes on bottom here for girls? Do we know? If we don't know, what is it?
A question mark or X. Like
Aha, yes, let's get algebraic. Oh, a question mark. So what happens here then when we cross multiply? 5 times x is 5x. Right? Because 5 times x is 5x. We have the equal mark, Natalie, right?
4 times 5 is 20.
4 times 52
Oh, 52.
is 208. Do we agree?
Yep.
Okay. So, 52 boys, 5 boys to 4 girls. Okay? So, there's going to be a problem with this problem. They didn't set it up very well. I think they meant to say,
Daniel had a question.
oh, yes, Daniel.
Bruce's mic isn't working.
Ah, gotcha. All right. So, Bruce, next time I'll try to make sure I look at that. Okay? So now, from here, Daniel, what are we going to need to be doing to solve this problem? Oh, do we see it? Natalie, can I come to
Divide
you?
by 5 and divide 5 by 208.
All right, Daniel, you nailed it. Divide by 5. Divide by 5. All right, and we get 41.6 girls.
Point
No.
six.
How could you have 0.6?
0.6, we can't. I'm thinking what they should have done. I think they should have said this was 52 girls, and made it across from the girls because 4 goes into 52 evenly. I'm thinking they messed up when they wrote the problem. Everything we said was good because it was 52 boys to girls. So they either should have done girls to boys or it should have been 52 girls. I think they set up their problem wrong. You guys, from what they told you, did it exactly right. But you know you can't get part of a girl, all right?
Maybe one's like
Unless you're a mass murderer. We don't want to go into that, all right? So, I'm thinking they wrote the problem wrong. So girls, 5, boys, 4.
Huh?
They wrote it wrong. They said the ratio of boys to girls. It should have said girls to boys. Because, like Christine said, the order is important, okay? So you guys did it all right. But now when it comes out, hey, 52, there would be 65 girls then, all right? Because there are more girls than boys, okay? You guys set it up right. Help me. That's slide 11. Not slide. That's slide 12. This is slide 11. All right, very good. My computer's slow today. All right, so slide 11, we need to make the change at the end. The ratio of cats to dog in a kennel is 3-2. Let's hope they did it right. All right, so Trenton, what are you saying the ratio is? 3/2. Now label the things, Trenton. 3 what? 2 what?
3 is cat.
All right, Carson, do you agree with him?
Yes.
All right, now Carson, as we look at the next part, if there are 48 dogs at the kennel, how many cats are there? So what does the other side of the fraction look like, Carson?
48 dogs over X cats.
48 dogs over X cats. Okay, Carson? You like that still? All right. They're saying no here in class. I heard some people say no.
No,
Why isn't that good, Carson?
because you can multiply dogs to cats.
No, that's not what we want. When we do proportions, what do we want, Tori? We want them to be across from each other like this, Carson. It should be cats and cats, dogs and dogs, all right? Because then you're seeing if one fraction is equal to the other. You're comparing the same things. So, Carson, when we do this, we're going to look to put, since dogs are on bottom already, we're going to look to put the dogs on bottom, and we're going to be looking to put the cats on top. So your numbers were right, but you flipped them around, okay, sir? Do you see that?
Yeah.
Yep, okay. That happens. All right, then 2x, right? 3 times 48 is 144. Okay. Well, 3 times 50 is 150 minus 6, right? Okay. Then from there, what do I do, Connor?
Take 144.
2. All right. Because we got to do this side by 2, so this side by 2. So how many cats are there, Trenton? 72. 72 cats. All right. Let's see if we set it up good or if they switch things around on us. All right. They did it exactly like us. There we go. And they get 72x, which is 72 cats. All right. Let's try one on our own. The banana slug travels 4.5 inches in 120 minutes. At this rate of speed, how long would it take the slug to travel 12 inches? So remember, you're going to want to have your equation or your fraction equals another fraction. Make sure you're labeling them so we can get into that next part. All right? I know you're doing mentally, but I want to see the answer out on paper. All right? So read that first sentence. Can I get that made up? Then, or get that fraction made up? Then the second sentence. Online at home, you can do it too.
Once we have the answer, what do we do?
Very good setup. Once you have the answer, raise your hand. I want to come check it. Good. I'm going to trust that your math is right. So, whew, yeah, it'll take a while. Very good sentence. So you got like this setup for the first fraction. So now let's think of the second fraction. Good setup, good setup. Oh, you gotta watch this calculations. Put an equal mark there just to make me smile. Well done, though. You're good. Okay. Very good. Your work is, or your stuff is great. Yes, yours is too. All right. Nice job. Good, Christine. Oh, good setup. Good setup. Okay. Oh, my only question is okay. So I need you to do one more step. So I'm gonna do this. X. And then do you see this? We have to take 12 times 120. So that should give us 1,440. Do you see how that changes when we do division with? Because we can divide by that. So you forgot that one step. Your setup for this equation is good though. Very good. All right, ladies and gentlemen, here's what I saw a lot of you with. Online, I'm going to check that you got this too, or trying to ask you if you got it. They had inches over 120 men, all right? So they put 12 inches over X men. They didn't know what it was. So 4.5X. Don't forget to put that equal mark there, realizing that, hey, we're just doing a cross multiplication, 1,440. And then they did the division. And you got 320 is X. And now, you know what we can make sure to make this? All right. Well, 4.5 will go into 12 like 2 times plus a little bit more, right? So 120 and 120 is 240. And then I need almost another 120. So the fact that this is a little less than 12 times 3 makes sense, doesn't it? Okay. So the setup I saw was good for nearly all of you. I had most of you set it up this way, but then I had another person that went 120 over 4.5 and X over 12. Did they set it up all right? Yeah, they just chose to look at it that way. And there's nothing wrong with that. All right, so then we do our math and we get that, and good job. Let's try another one by ourselves. All right, oh, the banana slug again? All right, so a cable car travels 15 miles in 80 minutes. At this rate of speed, how long would it take the cable car to travel 45 miles? So think, we've got this, got that. How do we set that up? The number, oh yeah, the number's messed up.
Well, what cars did you think? 15.
Oh, I see what you did. Because when you set it up here. Yes, you remember that from 6th grade. Good job. Now Jacob remembered a shortcut of old that I can show you. I don't want to mess up what y'all are doing though.
Oh, I remember. That's good.
No.
You definitely did not. You did the wrong word. Yeah. The other two next one are 40.
Yeah, it is.
Oh my god.
Where'd you get the 9 from?
Like the team that we lost to, like the same one, just like last week was one of the last
He's up. So what you might be. Oh, you reduced to make them even? Okay, you're not gonna be able to reduce it. When you have all the numbers, you can reduce to see if they're equal. But when you get to this, you want to be cross multiplying. You see how 15?
You could just tell why was in there was like 6'3". It says on Google. The NBA. Yeah, I was 44 points. I think it was low.
Unless he was only like 2 games and hit a bunch of threes and then, but still he would have been home just for a short time. All right, let's go. So with this equation, all right, Carson, what did you set up for the first side? Carson, you may still be on mute.
Hello.
Hello, we got you now.
Okay.
So what would it be for this left side fraction, Carson?
Left side. 15 miles over 80 minutes.
15 miles over 80 minutes. Miles. Okay. So then, Connor, what would this right side be?
45 miles over X minutes.
45 miles over X minutes. Good job, sir. Okay, so we've got that. Now, many of you went and cross multiplied and did all that. That is very good. So you got 15x equals 3,600 divided by 15 divided by 15, and we saw that this was 240 equals x. Now, some of you that are very confident in all that and very good, and you don't mind that little bit of extra work, that's great. Make sure you keep that up. But Jacob did this, and I saw Gavin did this as well. How do I get from 15 to 45? I multiply by 3. Oh, so if I do the same thing on the bottom, what is 80 times 3? 240. Do you see all that they did? They had this fraction times 3 over 3, 45 over 240. That only works out if they come out evenly, okay? Jacob saw this goes into that pretty easily. So you can take that shortcut. Do you see all that we're doing is just expanding the fraction, multiplying by a fancy 1? That will work. Lucas kind of saw it, but he was trying to divide down and go backwards, right? The reason you don't go divide down is because you don't have anything to work from here. So you start with that way, and that's why you look at the multiplying, okay? That shortcut will work. If you feel good with the 3600 equals 15x, I would do it that way because you guys are nailing that. But that is the shortcut because it is just like a fancy one, all they're doing. All right, so, oh my goodness, Summer. All right, you and Daniel get the next one for me. All right, so let's go ahead and do that. I'm going too fast for the board. All right. Summer, what do you think? Nate has 225 envelopes to prepare for mailing. He takes 30 minutes to prepare 45 envelopes. If he continues at the same rate, how many more minutes will he need until this? So help me set up the, you want to set up the whole problem or just one side of it, Summer? All right, very good. Go ahead and tell me what you want to tell me.
225 on the top.
225 on top.
Envelope.
And below is where?
Envelopes. And pocket.
Oh, envelopes, I'm sorry.
Then 30 minutes.
Okay, 30 minutes. All right, very good.
Oh, never mind. I read that wrong.
I like what you've done so far. You've done it wonderfully.
I'll go.
Okay? So then what goes over here, and I just put E for envelopes. I just didn't write envelopes all the way out.
Okay.
Oh, I see what you're saying. I'm sorry. She caught on to it before I did. So that shouldn't have been there, you're saying.
So it would be 45 over 30.
45 over 30. Very good catch. So what goes down here then? And X minutes. Because we don't know how many minutes it took to get all of the envelopes prepared. We do know how many minutes it took to get 45 of them prepared, don't we? Okay. That one is usually catching them. So you do have to read. Do you see how hers is different? It wasn't just the first sentence. Put the numbers in the second sentence. Very well caught, Summer, because I hadn't even looked at it yet like that. All right, well done. So what do we do from there then? You want to just continue to go? You're doing so well. All right. So what do we do then, man?
We get 45. No. Yeah. 45 and 7.
So we get 45x. Okay.
225 times 30.
Okay, and Taylor, what is that?
225 times 30.
Or anybody?
Times 30.
Yep. 6,750.
That's right. I got
We have an online calculator.
6,750.
What? You got 6,750? All right. And what did you get, Summer?
Well, I put 5.
Oh, okay. All right. So theirs was right. Okay. And then our final step here, Summer.
Take 45 divided by 45.
Okay.
Then you divide 6.
Yep. I knew where you were going. Good job.
Divide 150.
We may need to get you a simpler calculator. Okay. 150 minutes. So 45 minutes to do 30 of them. So 30 minutes to do 45 of them. So that makes sense. All right. We're good there. You guys feel pretty good? Feel ready to go?
Yeah.
All right. Let's work for a bit then. All right.
So
I'll come here so I can help you out.
serious this time?